let's evaluate a theory of acquisition for syntactic islands. So one theory was one that I worked on with John Sprouse back in 2013. And the intuition was simply learn what you can from the WH dependencies you observe in the input over time, right? And then apply it to generate behavior for WH dependencies you haven't seen before, like those that say cross syntactic islands, or maybe other longer WH dependencies you might encounter, right? Or shorter ones, or really any ones you might encounter. So then the key idea here is to view WH dependencies in terms of their building blocks and track those building blocks in the input to count those. And so dependencies here are going to be represented as a sequence of what we lovingly called container nodes. If you think of the different sort of phrasal nodes along a path, what phrases contain the gap, but not the WH word? So in what did you see? We have a VP and an IP are the two phrases that contain the gap. So we can characterize this as a start IP VPN for what did you see. You can do this for any WH dependency you like. So what happened is just a start IP, then end. Longer one, what did she want to do, right? And you can trace it down, IP VP, there's our gap. So that's start to end. And of course, you can also do this for dependencies that are, say, much less acceptable, like those that cross islands, because they're going to have low probability segments. That's the key idea, where a low probability segment is going to be made up of one or more low probability building blocks. So if children can break these dependencies into these smaller building blocks, that'll be noticeable, right? That'll matter. So then the building blocks are these then trigrams of container nodes, which I'm going to talk about as syntactic trigrams just for shorthand, but they're just trigrams of these container nodes. So you can break any WH dependency characterized this way into little chunks of 3, into trigrams. So start IP VPN might have these two building blocks. You can use the same ones in the longer start IP VP, end, but they're going to have a couple other ones in between. And you just generally, and you have start IPN for like things like what happened. And also in our longer dependencies that say cross syntactic islands are going to be made up of some of our more common ones, but also some low probability ones, hopefully some bad segments. And learning is just tracking the relative frequency of the syntactic trigrams in the input, counting them. And some of them are going to be common, countable, show up a lot. Some of them aren't, right? And ones like these might never occur at all, right? They're going to be really unusual. So what we then can do, our learner is going to calculate the relative syntactic trigram frequency, which is going to be the probability calculated this way, just the count of that particular trigram over the total number of trigrams with a little approximate there, right? So that we don't quite do it. We do a little smoothing to make sure that things that have a count of 0 don't get a probability of 0, they get something slightly more, right? And so any WH dependency can then be constructed from its syntactic trigram building blocks. That's it, and that's all. So, right, you can do, where in this case, you're just going to multiply them together to get the product. There are different ways of combining these probabilities, but here's the way that Pearl and Sprouse proposed back in 2013. So you just multiply them together and get your probability for any dependency you like. So you can have more frequent ones combined with less frequent ones, more frequent ones combined with really infrequent ones, right? That's fine. And then WH dependency's probability is going to stand in for its predicted acceptability or preference, right? So lower probability dependencies are predicted to be less acceptable or going to be dispreferred compared to higher probability dependencies. Like that's the link between the model output, its predictions, and the behavior that we talked about before about adult judgment patterns and child judgment patterns. So if we learn from the input children get the way this theory specifies, can this theory output the behavior that children should produce, either that they do or that they should as adults produce? That's the question. Well, okay, let's talk about what the input actually looks like. So for this, we took a sample from the child's tree bank, a speech directed at 25 children between the ages of 1 and 5 years old, about 102,000 utterances, about 21,000 WH dependencies. And this lets us estimate which WH dependencies children hear and how often they hear them. That is what the distribution of WH dependencies is in general to this this set of kids. And then we can estimate how many WH dependencies children hear during the learning period, which, as you recall, was just before they turn 5, like just under 60 months. So children begin, we know, to represent the full structure of WH dependencies, that is, say, WH questions, but also things like relative clauses, around 20 months, right? So what we can do with an educated guess is say, okay, this is when children can start processing WH dependencies reliably from their input. So the learning period is from 20 months to just under 60, so 20 to 59, basically. So, okay, how many minutes is this? Well, in particular, children are only awake for a certain portion of the day at different ages, and some people, for instance, this Davis et al. Paper, have calculated what that looks like. So, for example, you can estimate how many minutes by looking at the waking hours at different ages that are within this learning period to get something like 850,000 minutes. Okay, great. And, okay, so how many WH dependencies is this exactly? Well, from this, we look to people like Hoff-Ginsburg, 98, and Rowe, 2012, to get estimates of utterances per minute in speech directed at kids from different backgrounds. So, for example, the data that we estimated the WH dependency distribution from came from kids from higher socioeconomic status, SES for short, backgrounds. And so we can look and say, okay, what's, how many utterances per minute? The average seems to be just under 16, but there's a range from like 7 to 24 per minute, multiplied by the number of minutes. And then from our own corpus samples, we have the rate of WH dependencies per utterance. So this is the number of WH dependencies in our sample versus the total number of utterances, right? So, okay. And from that, we get a range of total WH dependencies from 1.2 million all the way up to 4.2 million. Okay, so can the modeled learner then produce the appropriate observable behavior? That's the question. Reminder, our target behavior was our super additive patterns for certain island types for adults, and then a preferred judgment for potentially ambiguous WH questions for kids. Well, let's look at the adults. Again, we're looking for super additivity in selected judgments, right? So our non-parallel lines for syntactic island knowledge. And the idea, again, is that each set of island stimuli from that adult study from 2012, say complex MP island stimuli here, which is crossing our two factors of matrix versus embedded, non-island versus island, can be transformed into its container node sequence. And then those can be broken into the syntactic trigram building blocks to have their probabilities calculated, right? And it's the probabilities that we can look at, relative probabilities. These probabilities can be plotted to see if superadditivity is present in the predicted acceptability judgments. And so if it is, then we would predict the modeled child has the syntactic island knowledge that allows the same judgment pattern as adults. And it's going to be this knowledge learned from the building blocks, these syntactic trigram building blocks in children's input. So this is what we find for complex MP islands, subject islands, weather islands, and adjunct islands. And lo and behold, everywhere we look, superadditivity is going to be predicted for judgments of all 4 island types. So, great, the adult patterns are there. What about the kid patterns where they prefer this interpretation? And so if we look, turns out that the WH dependency this interpretation relies on is a heck of a lot more probable than the other one, 10 to the 18th times in this particular case, but a lot. So the model child's going to prefer it too, right? So we have both types of behavior, adult and child behavior, accounted for. So our takeaway is that this theory can work for learning knowledge about syntactic islands, at least these syntactic islands. And the key idea is learning about the building blocks of WH dependencies leads to knowledge about syntactic islands.